Sir, for the end of semester exam, when we allow the formula sheet again, we have the formula sheet.
You have that, yeah. Yeah.
I realized what I did wrong.
What?
Very true.
Go on, what?
I multiplied 3 by 3 rather than 3 to the power of 2.
I'll try not to laugh. Okay. Alright, so. Continuing. Yes. Yeah. It's probably because I have my gig of RAM being used up right now. Let me just close that. And I'll close my calculator. You know, that's probably using up like 64 megs of memory, you know, just hogging it. Right. So what we're going to have a look at now, there isn't any new formulas in this lesson. We're simply going to use what we've learned from indices and logs, but apply them to practical problems. Okay, so we'll start off with a biology example, something like this. Okay, so let's imagine that we've collected some data and we're looking at the growth of some enzyme or something like that. Okay, so what we have here is time in minutes, and what we have here, have you done enzymes or anything like that? Look, actually, let's pick an example that you did in class. What graph did you do that produced an exponential curve? Substrate. Okay. So just tell me what was on the x-axis. Okay. What was on the x-axis? What was it? So what letter is that, or what did you? Concentration. C? Oh, the concentration of the substrate S. Okay. And what do you have on the y-axis? Activity, so just A, is it? And did column use units? What did you measure this is measured in molars, is it?
Yeah.
So this is measured in molars, and the activity is measured in?
Second per mole?
Second per mole? What the heck is that?
Mole per second?
For which, the activity?
Yeah, it was mole per second.
Mole per second.
Yeah.
Okay. Alright, so, the graph, maybe it looked something like this, but then petered out. So we're just going to look at the part of the graph where it behaved exponentially, and we will talk about the part after that in a moment. So it looks like this graph is behaving exponentially, so we think it might continue like this forever, and we would like to figure out a formula that represents this. And this is a common exam question. The story is different each time, of course, but the idea is the same. You have something growing exponentially, and what they do is they give you the values at two different times. So in the question it would say something like, when the substrate concentration is 0 molars, the activity would be, what might be a number here on your graph, if you remember? Are we talking like decimals, or are we talking like 0.1, something like this maybe? So the activity could be 0.1 molars per second. And then they'll give you another piece of information in the question. They'll say something, they'll say when the substrate concentration is equal to, what value would be here? What unit? How big are you going up in molars, or 0.1 molars? How big are you going up on the x-axis? Just roughly. It could be 1 molar or 2. Okay, we'll go up to 2 here. So when we say it doesn't matter. We'll just say when the substrate concentration is 2 molars, then the activity should be more. We'll say the activity increases to say 0.5 molars per second. So if you were to mark it on the graph, this point here would be 0.1, and this point here, what would that be? That would be 2 and 0.5. That's a 5 there, like that. Okay, now, the next step, which is common in the exam, is you have to write down what formula you think this graph looks like. And there's no surprise here, it's the same each time. It'll be in this form, y equals some constant, I don't want to use the same letter, b, e, some constant, and t. And your job is to figure out the constants, the b and the k. Right, so this is now ready to start the answer, because all of this is actually just information in the question. Now we can start the answer. So what do you think I should do first if I'm trying to figure out the b or the k? Which is actually easier to get first? The b is actually easier to get first. But how can we get that? We can get that by substitution. We can sub in a point. We know that 0.1 is on the graph. So we can say 0.1 equals b, e, k, and the t is 0. Now what does this tell me? This gives me b equal to what here? What is it? B is, because what's e power 0? Okay, I think you might figure out what happens next. What do we do next? Too late now. We substitute in the other point. So now we get 0.5 equals b, but we know b. E, k, and what's the t? For the second point? No, for the second point.
2.
There we go, 2. Okay, this is a little bit harder. We have to figure out the k here. So how can I go about getting the k? What should I do here? Not log yet. Little early for log. There's something to do before that. Divide by 0.1. So 0.5 divided by 0.1 is 5. Okay, what's next? Next? Yeah. So the log and the e cancel. So you're just left with 2k equals log 5. So how do I get the k? Yeah, it's divide by 2. Yeah, log 5 all over 2. So what's a half log 5, please? Give me 3 significant figures. 0.805. So the answer is the activity will equal 0.1 e 0.805 t. That's the formula for activity. Oh, sorry, not t. Oh, flip! I kept calling it t, didn't I? It's not time. It should have been substrate concentration. Okay, I'm pretending that's the letter T in my algebra. But really I should have had an S here, shouldn't I? Yeah. Now the reason I was writing down T all the time instead of S is because in the exam it is usually time they have on the x-axis. Because something, like for example, a couple of years ago it was the price of a hotel. So the time is on the x-axis, Or the year after that it was bees in a beehive were increasing their population, so it was T here. In fact, when I think about all their examples in the exam, they always put T on the x-axis, and then Y is whatever you're measuring. It's always like this. Like like question 1 I have here, I'm measuring temperature, where temperature is on the y-axis and time is on the x-axis. Okay. Now, a normal, so actually I'm sorry about the t, if that confuses you, you can either replace the s with a t here, or replace all my t's with an s, whichever you prefer. Okay, let's look at another one anyways. Oh, no, before I do, it's common in the exam that they ask a follow-up question for 1 mark. So a common follow-up question would be something like, predict what the activity would be when the substrate concentration is 3. So how would you do that?
Just multiply 0.805 by 3.
Yeah, so just put in the value of 3, and then you get it here. So can someone put that in? What do you get for that? It's going to be like 0.6. Oh, what is it?
1.11.
Okay, 1.11, yeah. And then finally, a final question for another 1 mark only would be, do you think this formula holds true for all levels of substrate concentration?
No.
No. Well, you know it doesn't because of what you did in biology. Yeah, well, why doesn't it hold true? What would you say for your 1 mark? What would you say?
Do you want us to answer in bio or in
Well, you could answer bio in the exam, but suppose it was a topic that you knew nothing about.
okay.
So what would you say?
Well, it does not go on to infinity.
Close. We could spin that a little bit better. So we could say something like,
There's points on
Conversion.
where it's 1 though.
yeah. You could say that there's a point on the graph where it stops behaving exponentially because it cannot continue up to infinity. So, So no, what you're saying is right. There's a biology reason for it, but it's true for every situation. If you're talking about the price of a hotel, can the price continue up to infinity? No. If you're talking about bees in a beehive, again, it can't increase up to infinity. So it doesn't matter what the situation is. The answer would be, it stops behaving exponentially because it cannot continue unlimitedly up to infinity, unbounded. It has to kind of reach a ceiling.
Can we call it convergence?
Yeah.
Call it what?
Conversion.
Convergence.
Then we would find like the.
Okay.
We would find the.
It converges.
Point where it converges.
It converges because it reaches some practical limit.
Yeah.
Yeah. Okay, let's have a look at another example now. Oh, you need to write this down? Okay. Okay, have we got that? Hang on a minute. Right. Have we got that? Okay, continue. So let's look at a chemistry example. Whoa, zoomed in too much. Okay, chemistry example. So in chemistry, I hope you've done this fact, that the pH level of something is given by the formula minus log base 10 of the concentration of H plus. Isn't it?
Haven't done this yet.
You haven't done it in chemistry yet? No, okay.
Yeah.
Anyways, no matter. I'm telling you this now as a fact that you will soon discover in chemistry class, that the way to calculate the pH of a liquid is it's minus log base 10 the concentration of H plus. You all know what H plus is from chemistry. You all know what concentration is. It's measured in moles per litre. Okay. So, let's say we're looking at something like orange juice, OJ. The pH level of orange juice is 4 because it's an acid. So it should be, you all know that acids have a pH of less than 7. So what I want you to do, I think you can all do this, just take a minute, tell me what the concentration is. If the pH is 4, you should be able to work out the concentration. Okay, so try that for a minute. So find H plus concentration. So that's part 1. Okay, we should be getting answers coming in now. Many answers? Concentration is 4? Doesn't quite seem right. 10 power minus 4? Sounds right. So look, you need to figure out what the H plus is if you're saying 4 equals minus log base 10 H plus. So what I'll do first is I'll multiply by minus 1. So I get minus 4 equals log base 10 of H plus. And then you just have to remember what logs mean. So log means 10 to what power here? Minus 4 equals H plus. So the concentration for orange juice is 0.0001 and the unit? Moles per litre, also called molars. So I'll just write it as moles per litre like that. That's the concentration of H plus in orange juice. Okay, part 2 now. So here's my next question for you. So here's my glass of orange juice. Let me make it yellow. No, orange. What am I saying? Yellow. Orange juice. Yeah, no, I know what colour it is.
No, it's not.
Close enough. Close enough. Right. So you have 200 milliliters of orange juice. So my question is, I want to know the constant. I want to know how many moles of H plus is in this. Okay, so I want the number of moles of H plus. So how many moles of H plus in this one here? So this isn't really a log question, it's just a chemistry simple maths question.
That's 200 what?
Milliliters. Do you use milliliters in chemistry or use a different unit? Yeah, same thing. 200 centimeters cubed if you preferred. How many moles of H plus are there in this orange juice? The concentration is the same, of course, yeah. So what do I do here? How do I get the answer?
Convert it to liters.
Ah, yeah, but there's a quick way to get the answer. What's the quick way to get the answer?
Just multiply by 0.0.
No, come on. Quick way.
Multiply by 10 to the power minus 4.
No.
Multiply by 10 to the power minus 4.
That is mole per liter. So, and we already have milliliter. Convert it to liter and just use.
Yeah, but you're making so much work for yourself.
Find the number of concentration and moles.
Guys, you're not... Look at the numbers I gave you. There's a very quick way to get to the answer. Thank you, yeah. You have 200 milliliters. How much of a litre is that? That's a fifth of a litre. Isn't it? 200 millilitres is a fifth of a litre, because how many millilitres are in a litre? 1,000. And if you have 200 millilitres, you have a fifth of a litre.
1/500.
So, now listen, you have a fifth of a litre. You just figured out that you will have 0.001 moles per litre. So if you have a fifth of a litre, you will have 1/5 of this. So just divide by 5. So the answer is the number of moles is equal to 0.00002.
So 2 to the power minus 5.
Yes. Yeah, but I didn't want you wasting your time going, oh, I'll do this and I'll convert this. And I just want you to see that the answer should be 1/5 of the previous answer. Okay, number 3 now. And then we'll do another question after this. I want to know the number of H plus atoms in my orange juice now. So how many H plus atoms do I have in my orange juice?
Given that it's 200.
It's all the same info, 200 millilitres of juice. A standard glass size of orange juice. Times Avogadro's number, yeah, so it's 0.12342 times 6.02 times 10 to the 23. So what do you get there? You sure do.
is
10 to the
19.
19. Okay. Alright, so you've just worked out how many atoms of H plus is in your morning glass of orange juice. Okay? Interesting enough, I thought. Right, let's have a look at another one now. We'll do something like we'll do something like this. Can I scroll down?
Yeah.
Right, I'll give you one to try just to see if you're getting the idea. So, this is normally what happens when you look at money in a savings account. So you start off at year 0 and you put some money in. So let's say we put in 1,000 euros. And then let's say like 1 year later, it will increase to, let's just say, 1,010 euros. Now, I know that doesn't seem impressive, but this graph is actually exponential. So when you deposit money in the bank, okay, it feels like this for a long time, but eventually it shoots up. The only problem is you tend to spend your money before that happens. So what I want to know, I'll give you, so it will slowly increase up. I am looking for the A and the B here. And this is for your money, so we'll call this M for money. So I want you to figure out the A and the B for me. So that's part 1. Can you try that now? Get me the A and the B. Yeah, get me those two constants. Yeah. Got that, guys? I think you should have the A by now. So if you sub in the first value, you get 1,000 should equal A, E, B power 0. So what's the A? 1,000. So now if you sub in the second value, 1,010 equals A, E, B, and what's the T?
1.
1. Okay, so how do I get the b here?
Log.
No, no, no. First divide by 1,000. I'm going to divide by 1,000 first, and then log. So I have my b as log of whatever 1.010 is, which is it? So again, 9 point. Yeah. Minus 3. So it's 0.00995. Yeah. So you've worked out that your money will behave according to this formula. 1,000 e power 0.00995 t. Okay, so question 2, now that you've worked that out, answer is when will you have 2,000 euros? So I want to know how long will you have to wait until your money grows from 1,000 to 2,000. So how many years? If you can calculate that. Not the answer. That means you've gone from 1,000 to 2,000 in like 8 months. Not 10. Any answers? Okay. Days? No, that would be a super bank. Say again? Correct. Yeah. So how many years is that? If I said, how long will I have to wait until I have 2,000 euros? How many years do I have to wait?
69 years.
No, but give me a number of years, a whole number. 70 years. 70 years. Because if I wait 69 years, I'm short a couple of euros. I have to wait 70 years before I can hit the 2,000 mark. So, how do we get that? What you do is you just make the money equal to 2,000 and you solve. So what's the best way to solve this? What should I do first? Divide by 1,000. And then next, log. They cancel. So this I think is 0.69 equals 0.00995 t. So I divide by that. And I'll get t is, what is it, like 69 point something. But you have to round it up if I ask you how many years. So the number of years is 70 years. So, it's because the interest is quite low. The interest rate here is 1% a year. So you'll have to wait 70 years before you can double your money then. Yeah, it's not great. Yeah, correct. So that's what I'm saying. You never see the exponential part because you're dead before that happens. So the graph, the graph will go like this. But here, yes. Yeah, so. No. Maybe not. Okay, so look. You really need to try all of these. There's 10 questions there, okay? And some of them are quite hard. Some of them are physics, some of them are chemistry, some of them are biology. They're all about using powers and logs to figure out the answer here, okay? So just try these for a few minutes.